Good day everyone. Today we'll be starting with part 5 Electrochemistry of chapter 2 class 12. We'll be studying about electrolytic cells in this part. So the electrolytic cells are those cells in which the electrical energy is used to carry out the non-spontaneous chemical reactions, and the reactions taking place in an electrolytic cell is called electrolysis. It is very important to understand what is electrolysis. So electrolytic cells are those which will convert the electrical energy to carry out non-spontaneous chemical reactions, while the reactions which are happening in electrolytic cell is called electrolysis. So the electrolysis will involve the chemical decomposition of the electrolyte by the passage of electricity through its molten or in the ionized state. In an electrolytic cell, we have an external source of voltage which is used to bring about the chemical reaction. One of the simplest electrolytic cell consists of two copper strips and which are acting as anode and cathode, which will be dipped in an aqueous solution of copper sulfate. So the diagrammatic representation is as follows. So from anode the electrons will move and they'll pass through the external source of voltage and then will again come and deposit at the cathode. And the working at cathode will be like Cu2 plus the received 2 electrons will give rise to the deposition of copper, while in the anode the copper will be broken down and 2 electrons will be released. So in the industrial purpose or processes, impure copper rod is made as an anode, and on the passing of the electricity we'll get the pure copper rod at the cathode. Here the Cu2 plus 2 electrons will give us the proper pure copper, and thus in an electrochemical cell the cations are attracted towards the negative electrode and the cathode, that is the cathode, and it will accept the electrons. Hence reduction will occur at cathode. That is in contrast to the galvanic cell in which cathode is a positive electrode. So the anode is in an electrolytic cell is positive electrode where oxidation of ions will occur, and therefore it will be in the reverse of the galvanic cell where we have the reduction at cathode and the oxidation at anode. So the applications of electrolytic cell are many. Metals like Na, Mg, Al are produced in large scale by electrochemical reduction of their respective cations where no suitable chemical reducing agents are available for this purpose. Now let us study the Faraday's laws of electrolysis. So basically the quantitative aspect of electrolysis was studied by Michael Faraday, and his laws of electrolysis are known as Faraday's laws of electrolysis. So Faraday's first law states that the amount of chemical decomposition occurring at any electrode by passing electricity is directly proportional to the quantity of electricity that is passed through the electrolyte. So here we take W to be the weight of the substance, while Q is the charge which is passing. So here W is directly proportional to Q, and we remove the proportionality sign, we get a constant Z which is called the electrochemical equivalent, which is the amount of substance deposited when 1 ampere of current is passed for 1 second, that is the Z. So we get the final formula W is equal to Z into IT, where we can write the Q to be I into. Now the Faraday's second law. It states that when the same quantity of electricity is passed through different electrolytes connected in series, then the weight of different substances liberated at the electrodes is directly proportional to their equivalent weights. So here equivalent weight is the atomic mass of the metal divided by the number of electrons required to reduce the cation of the metal. So we get W1 by E1 is equal to W2 by E2, which goes on to Wn by En, where W is the mass of the substance and E is the equivalent weight. Here W is the by E is a constant for all the values, so they are directly proportional. Now we'll study about the Faraday's constant. So the amount of electricity or charge required for oxidation or reduction depends on the stoichiometry of the electrode reaction. So we take this example, that is Ag plus 1 electron will give rise to Ag, which is, this is aqueous and this is solid. Here we get a Ag plus. So here we have 1 mole of the electron is required for the reduction of 1 mole of silver ions. So the charge of 1 electron is 1.6 into 10 to the power minus 19 coulombs. And therefore the charge of 1 mole, which we have to multiply with Na, whose value is 6.02 into 10 raised to power 23. So when we calculate, we get the approximate value to be 96,500 coulomb per mole. So the quantity of electricity is called the Faraday's constant, which is represented by symbol F. So by combining the Faraday's laws, we get the final expression of Z to be equal to E by F, which is equal to W by Q. Now let us solve a question. So the question is, an aqueous solution of copper sulfate CuSO4 was electrolyzed between platinum electrodes using a current of given amount for 50 minutes. We have to write the cathodic reaction, the electric charge passed, and the mass of the copper deposited at the cathode. So simply the cathodic reaction will be Cu2 plus 2 electrons will give rise to Cu. This is in aqueous state and this is in the solid state. And we can find the charge, which is with the formula I into the time which is given 50 minutes. We'll convert the 50 minutes into seconds and get the final answer to be 386.1 coulomb. And we have to find the mass. Mass is equal to Zi and the time. So here equivalent weight by F. We know the formula of Z to be E by F. And after the final value would be 0.127 grams. Now the products formed during electrolysis will depend on the following factors. So the products of electrolysis will depend on the following factors. First factor is the nature of material being electrolyzed. So the products of electrolysis depend upon the standard electrode potentials of the material or the electrodes. Also, the nature of electrolyte will help us in the process of electrolysis. In case of strong electrolytes, the process becomes fast, whereas in the case of weak electrolytes and the electrodes which are being used. So if the electrode is inert like platinum, it will not participate in the chemical reaction and acts as a source and sink for the electrons. So if the electrode is reactive, and then it participates in the electrode reactions. Hence, according to what electrode we use, the electrolysis products of the same electrolyte may vary. And the nature of species present in the electrolytic cells. So here, the product of electrolysis will depend upon the different oxidizing and reducing species and their standard electrode potential values. Cathodic reaction takes place with higher reduction potential, while anodic reaction will take place with higher oxidation potential. And the kinetic barrier or the over voltage. So some of the thermodynamically feasible electrochemical processes are so slow kinetically that these do not seem to have or function at low voltage. Hence, extra voltage or over voltage is required for them. Now let us study some examples of electrolysis. So the first example is the electrolysis of molten sodium chloride. So it produces sodium metal at the cathode and chlorine gas at the anode. So at cathode we have the reaction like Na plus 1 electron will give rise to Na, which is solid. In anode, 2Cl minus will give rise to Cl2 plus 2 electrons. Next we'll study the electrolysis of copper sulfate solution. So here, in very inert electrodes, the CuSO4 will become Cu2 plus SO4 2 negative. And at anode we have the reaction with H2O, and at the cathode we have the reaction with Cu2 plus. and the copper will be deposited at the cathode and O2 will be liberated at the anode. So please write these reactions in the comment section if you understood this following equation and the process of electrolysis. Until now we have completed the electrolysis, and the next part we'll be studying about the electrochemical cells in action, the batteries, mercury cells, secondary batteries, primary batteries and everything, and we'll wind up the chapter. Thank you so much for watching. Stay tuned for more updates.